So hello, welcome to chapter 3 example problems, where I'm going to go through a bunch of problems. Um, like last time and like every time, a lot of these are going to be similar to the type of things to expect on exams and also similar to the type of things on homework. This first problem is a little simpler than something I'd put on an exam, but the second, third, and fourth are all old exam problems. The fifth one, which I probably won't do in class today, is actually a little more difficult than an exam problem. And it's something harder than I would ask you to do, just because it involves you knowing how to use the quadratic equation. So I'm going to jump right in unless there's any questions. Okay, jumping right in. The first problem says, to get the shots of cars flying through the air in movies, it is sometimes necessary to drive a car off a cliff and film it. Suppose a stuntman drives a car horizontally off a 10-meter high cliff at 20 meters per second. How far does the car land from the base of the cliff? What we're going to do is we're going to have to define all of our terms. I always like to make the ground zero. And so I'm going to say this car is going to go off a cliff till it hits the ground. But it started on a 10-meter high cliff. That means it started 10 meters up. And I'll say y naught is 10 meters, y final is 0. That is arbitrary. You could sign that differently if you so please, but that's the way I chose to do it. I always make the ground 0. I also always make x naught 0, no matter what. And I even didn't even include x naught in my equations over here. Because it's just easier to always make x naught 0. Y naught is not always 0, as you can see, but x naught is. And our goal is to find how far away from the cliff it lands, aka what is its x value. Now, all projectile motion problems will come in one of two situations. Either I'll give you x and ask for y, or I'll give you y and ask for x. This is one where you know y and you want x. And so the process is always going to be the same. The process will always be find the x component of your velocity, find the y component of your velocity, and then use one of these two equations to solve for t and plug into the other one. Now this one didn't give an angle. It just said it went off horizontally. But the thing is, that word, that horizontal, I can treat that as an angle. If it's going off horizontal, which is what I drew here, that means it's coming off flat straight along the x-axis. If it's flat, what I can say is that my angle, my pen isn't working, is 0. Come on. It's like a brand new pen too. I'll say that angle is 0 degrees. Let me just write that again because that's also messy. Because it's coming off straight along x. Now I can use those equations, v naught x equals v naught cosine theta and v naught y equals v naught sine theta. But I can just logic it. Take a look at v naught. It's straight to the right. If it's straight to the right, that's all in the x direction. In the y, there's no component in the y because none of it is pointing up or down. I also could, as I said, use the equations. V naught x equals v naught cosine theta, where theta is 0. The cosine of 0 is 1, so that's v naught. V naught y equals v naught sine theta. Oops, sine 0 degrees. I meant to say 0. The sine of 0 degrees is 0, so it's 0. If I went for the logic of actually using the equations, I'd get the exact same thing. But I can say, okay, in this problem, I know y. So that's the equation I'm going to start with. I know that it goes from y naught equals 10, and it goes from y naught equals 10 to y equals 0. Since I know y, I'll start with my y equation and use my y equation to solve for t. And I'll just say y equals y naught plus v naught yt minus 1/2 gt squared. I'll plug in my zeros. And now I'll solve this for t. To solve it for t, I'll add 1/2 gt squared to both sides. Multiply both sides by 2. Divide both sides by g. And then square root. And I'll just do that math. Was it 10 meters up? 10 meters up. Oh, 1.43 seconds. And that tells me the time it's in the air. That it's in the air for 1.43 seconds. That's the total amount of time I have. Now, that wasn't the question. The question was, how far does it get? What's the distance in x? But now we can solve it, because now if we know how long it travels in x, we can say how far it gets in that time. Now that we have time, I'll just switch to my other equation and say, if you want to know how far it gets, well, x equals v naught xt. And we know v naught x is 20 meters per second. And I just found time. I said time was 1.43 seconds. And I can get a value, 28.6 meters. Did that in my head, so I should check to make sure it's right, but it is. That's the general logic. Now, this is easier than something. There's one problem on the homework like this, but most of the homework problems are a little harder. And the exam will be a tiny bit harder too. Because all the velocity was just in x and nothing was in y. It was horizontal. The angle was 0 degrees. But this process is basically the same. You're going to have to take your v naught, break it into components. And once you break your v naught into components, you'll go and say, okay, what is the x component? What is the y component? Oh, sorry, once you get your v naught into component, sorry, you'll use your two equations. You either use your y equation to solve for t and plug into the x, or your x equation to solve for t and plug into y. Any questions? I'll do another problem. Now, this one is an old exam problem and is about the level that you should expect. As I said, the exam might be I solve for x and I give x and ask for y. It might be I give y and ask for x. I think I said the same thing twice, but maybe I give y, ask for x, or I give x and ask for y is what I meant to say. But it could go either way. This is one of the two examples. In this one, this was on the exam a few years back when Pokemon Go was still super popular and it wasn't just like only my wife still plays. And what it says is a Pokemon trainer sees a Charizard, throws a Pokeball at the Charizard to catch it. The trainer throws the ball with a velocity at 15 meters per second at an angle of 20 degrees. Okay, I'm going to pause right there. Velocity of 15 meters per second at 20 degrees. Anytime you're given a velocity at some angle, anytime you're given any vector at some angle, get ready to split it into components. And for the velocity, I would say, okay, that 15 meters per second, 20 degrees, that needs to get split up. That's going to have to turn into my v naught x and my v naught y. Well, v naught x is v naught cosine theta. Or in this case, 15 meters per second cosine of 20 degrees. Which, if I do that math, is 14.10. My v naught y is always going to be v naught sine theta, or 15 meters per second sine of 20 degrees, which doing that math is 5.13 meters per second. I am not going to use v naught being 15 for anything else. That's just a way to get to this point. Now that I'm at this point, now I can solve. Now, and I got to figure out how. So it says, the Pokeball hits the Charizard at the same height from which it was thrown, which means y equals y naught. How far away? Well, if it's saying how far away, that means I'm looking for x. X is my unknown here. So I need to use y, but I do know y. What I say here is that y equals y naught. I didn't actually explicitly say what y or y naught is, but if y equals y naught, well, there's two ways to look at it. One is you could say I'll just define y naught equals 0. And if y equals y naught with 0 and 0, we're good. You could actually skip that step and they would still cancel out. But if I tell you y equals y naught, that means you know more about y. I know stuff about this equation. And now that I know stuff about that equation, I can use it to get t. I can say y equals y naught plus v naught yt minus 1/2 gt squared. Now, if y equals y naught, these are both the same. I can subtract them from both sides. And that would be the same as 0 equals v naught yt minus 1/2 gt squared. I can also just set them equal to 0 and get the same thing. What I would do is I'll add 1/2 gt squared to both sides. Divide both sides by t. Multiply both sides by 2. Divide both sides by g. Quick thing. I'm going to talk about this more not next week, but the week after when I talk about exam 1. I do grade heavily partial credit. You will get points for correct equations. I will give you points just for writing this equation or this equation or this equation, or when I get there, or this equation. I don't give points for jumped in. If you jump straight to this equation right here, I would not give any points for that equation. That's not the fundamental equation. That only works in a special situation. If you go straight to an equation that only works in a special situation, you happen to guess the right one, I'm not going to give you anything. But anyways, that's how long the Pokeball is in the air. That's how long, I should have grabbed a Pokeball from downstairs. That's how long it takes it to go up and over. Now that we know how long it's in the air, we can say how far it moves in X, just like my car in the last problem. We haven't used blue. Oh, we have used blue, haven't used green. And I can say, now that I know how long it spends in the air, I can see how far it moves. I'll just say X equals V naught XT, or X equals 14.10 meters per second times 1.046 seconds, which is 14.7 meters. Now note, V naught X is not 15. V naught Y is not 15. V naught X and V naught Y, I have to use these numbers respectively. That's the place people go wrong the most. The biggest mistake I see here is people using or interchanging V naught Y, and V naught X. Any questions? Am I good to go to the next one then? Okay, the next one is also an old exam problem. It's from back when we could like be social and be around people and have parties and, you know, not sit home alone in a house, or not alone, have a wife, but not sit home, like not seeing anyone outside the household ever. And it's about people playing beer pong. And it says, a student, in an effort to forget about physics, plays some beer pong. A student throws a ping pong ball at an angle of 30 degrees above the horizontal with an initial velocity of 3.77. Okay, I'm going to stop right there. Initial velocity of 3.77 at 30 degrees. Okay, that means I can get my V naught X and my V naught Y. Because V naught X is V naught cosine theta. V naught Y is V naught sine theta. And so respectively, I'll have, I got to remember to move my thing that has the numbers in. I'll say my V naught X would be the 3.77 meters per second cosine of what, 30 degrees? 30 degrees, which is 3.264 meters per second. And V naught Y is 3.77 meters per second sine of 30 degrees, which is 1.885 meters per second. Okay, now that I have that, let's actually read the problem and try to solve this. So they say they are standing 2 meters away from the cup they are aiming at and release the ball 0.8 meters above the top of the table. The ball goes in the cup. What must the height of the cup be? Okay, I'm going to zoom in a little bit. It's going to actually, I'm just going to cut off a little bit of the text, but I want to zoom into this picture for a second. See, what I'm saying here is I'm saying it's released from this point and goes in right there. And for the record, I started backwards. I measured the height of a red solo cup and then solved for it. So you have to know the cup in meters, you get the right answer. But what I'm saying is it travels a distance 2 meters. That means what I can say is x naught is 0, because x naught is always 0, but it travels 2 meters. It starts its y naught value, it starts 0.8 meters up, and I want to find y. That's what I'm getting at here. When in doubt, if you can't get it from the text, my pictures can sometimes help. I put a y here and I put a 2 meter there. Kind of gives a hint that I know the x and don't know the y. And so in this one, it's the opposite order. I know x. X is 2 meters. I want y. Oh, I want to zoom out one more time so I don't cut off my text. Wish we could get somewhere in between that. You know what? I'm not using the edge of the paper. Let's just do that. Now, since I know x, this time I'm going to start with my x equation. I'm going to say I know x. That is how I'll get t. The secret always is getting t. And so I can say x equals v naught xt, which means dividing both sides by v, that t equals x over v naught x, or 2 meters over 3.264 meters per second, which is 0.613 seconds. Now I have time. You see, if I have time, I can figure out the height, because I want to say if this goes pew like that, I want to figure out how high it hits the cup. What I'm going to have to do is I can figure out how long it's in the air. And I know how long it's in the air now. So I'll take that time and plug into my y equation. Y equals y naught plus v naught yt minus 1/2 gt squared. And I lied. I am going to make this smaller again because I'm going to go wide. And so I'll say the height y, go down here, is 0.8 meters plus v naught y, 1.885 meters per second, times t, 0.613 seconds, minus 1/2 g times t squared. And I'll just type that into a calculator. Oops. Units. That's the height of the cup, 11 centimeters. See, the process is different going this way. Now that I'm saying what is y instead of what is x, but the equations don't change. All projectile motion problems, all of the ones I'm going to ask of you, we'll just use these equations. That is how you're going to do it. This is the answer. Use those equations. Your homework for next week, it's got a lot of projectile motion problems. Here you go. Okay, any questions? Okay, let's do problem 4. Problem 4 is from the game They Never Stop Making itself, Skyrim. This is also an old exam problem, but it's slightly different. See, I always said I'll either give you X and ask for Y, or give you Y and ask for X. And this one I kind of shifted a little bit. And I said, the Dragonborn from the video game Skyrim uses a dragon shout power to launch a bandit off a cliff. The bandit leaves the ground with an initial velocity of 35 meters per second at an angle of 20 degrees. Okay, let's even stop reading the problem. V naught x equals V naught cosine theta. while V naught y equals V naught sine theta. And so V naught x is going to be 35 meters per second, cosine of 20 degrees, which is 32.59. And V naught y is 35 meters per second, sine of 20 degrees, which is 11.97. Okay. If the bandit hits the ground 144 meters from the cliff edge, how high is the cliff? So what I'm saying here is we know x. X is 144 meters. But here's the thing. I said before I like to always make the ground 0. If this person goes shooting off the cliff and goes, that's a horrible parabola, but whatever, and then hits downhill, that means I'm going to say that the y, I know that also. They're hitting the ground with y equals 0. What I don't know here, and if you weren't sure what I didn't know here, there's the whole, when you see a question mark on a figure, is why not? And this is the same as not knowing why. If I, instead of asking for why, ask for why not, it's going to be solved the same way. I know x. I'll use x to get time. Once I get time, I can plug into my y equation. Just I'll solve for why not instead of y this time. And so yeah, I'll start with my x equation. X equals v naught xt. Dividing both sides means t equals x over v naught x. Or 144 meters over 32.59 meters per second. That math is a 4.38 seconds, which is a decent amount of hang time for someone to be flying through the air. Now that I know the time, I can solve for my y naught, because I'll just get my y equation. Y equals y naught plus v naught yt minus 1/2 gt squared. I'll plug in my zeros, which is just y. And I'll rearrange. See, if I want to solve for y naught, I'll add 1/2 gt squared from both sides, and I'll subtract v naught yt from both sides, and say y naught equals 1/2 gt squared minus v sub yt. Just subtracting them over. And it'll be, okay, 1/2 g t squared minus y naught t The cliff is 41 meters high. That's the process. That's how you solve these. They're very repetitive, admittedly, but you're just going to go break your V naught into components. Actually, there we go. Break your V naught into components. Once your V naught is components, either use y to get t and plug into x, or use x to get t and plug into y. One or the other. That's the process. That's all there is to it. Okay. So as I said before, I only go half-length classes on Fridays because I'm hoping you're looking at these problems on your own ahead of time. So probably no one is. I should check that just out of curiosity. So I will stop there. Homework for this chapter is going, what's today? I don't even know what today's date is. Say the 19th? Yep, today's the 19th. Homework for this chapter is due on Wednesday the 24th. The lab on this chapter is due Thursday the 25th. That's where we're at. Have a good weekend. I'll see you next week. We'll start chapter 4, which I'm going to be honest, chapter 4, hardest chapter of the entire class. But, at least we get it out of the way quickly or something. I don't know. Bye.